In this video, I'm going to talk you through correlation, and I want you to approach this conceptually. Correlation is a numerical measure of the relationship between two variables. In other words, how do those two constructs or variables, how do they change in relationship to each other? So let me give you an example. I've got a group of kids and I want to see if there's a relationship between their age and their height. This is pretty intuitive, but it will help you to understand. Notice that I've got one group of kids, and for each of those kids, I have two variables. I have their age and their height. So the variables are what I'm measuring, not the kids. I've got one group. I can take the data about those kids and put them on a simple scatter plot. So on the x-axis, I'm going to put my predictor, or the x variable, the age, and on the y-axis, I'm going to put the criterion variable, or the y. So this is going to be their height in centimeters. And then I put a point on there for each data point. So for example, you can see here's Max. He's 7.1 years old and his height is 114 centimeters. Now when I look at this pattern that emerges in the scatter plot, that's what the correlation is all about, is this pattern that emerges. You'll notice that as the age of the children increases, their height increases. Makes sense, doesn't it? In fact, if I look at the average for their age, which is 7.3, and the average for their height, which is 116 centimeters, the children who are above the average for age are also above the average for height. The opposite is also true. Those who are below the average for age are also below the average for height. So as their age gets larger, their height gets taller. And the smaller the x, the smaller the y. So as x increases, so does y. This is what we call a direct or positive correlation. And the pattern rises to the right. As x gets larger, so does y. Now let's look at the opposite. In this case, I've got a bunch of kids in an elementary school, and I've been noticing that as the older kids don't wear their bike helmets as much as the younger kids do. So those 4th and 5th graders, they're just not wearing their helmets as much as the younger kids, I think. So I take all the 5-year-olds, and there are 74 of them, and I count, and 93% of them are wearing their helmets when they leave school. And if you look down to the 10-year-olds, those 4th and going into 5th graders, there are 78 of them in my school, and 74% of them are wearing their helmets when they leave. So I think there's a relationship between as the kids get older and whether they're wearing their helmets or not. When I plot this, I'm going to put their age on the x-axis, the predictor, and I'm going to put the percent with helmets, the criterion or the y, over on the y-axis. And this is the pattern that emerges when I plot the data points. And if you look at as their age increases, the older kids, fewer of them are wearing their helmets. So the percent who are wearing helmets is actually decreasing. And if I look at the averages, so the average age is 8, and the average for wearing helmets is 86% of them are wearing helmets. In this case, the kids who are below the average for age are above the average for wearing their helmets. And the opposite is true. If they're above that average age, they're generally below the average for wearing their helmets. So in this case, you can see that the trend or regression line is falling to the right. It's going down. So as the X, as their ages get older, there's fewer wearing their helmets. There's a smaller Y. And when there's a smaller X, there's more of them wearing their helmets. So there's a larger Y. In this case, as X increases, Y decreases. So this is an inverse or a negative correlation. Negative does not mean something negative, something bad. It simply tells you that the trend line is falling. As X gets larger, Y is getting smaller. So with correlation, we want to actually eventually put a number to this. So as X is going up, Y is going up. That's a positive or direct relationship. And as X is going up, Y is falling or going down. And that's a negative or an inverse relationship. So now let's put some numbers to this. It turns out when we do the mathematics, we use what's called the Pearson R. R is equal to 0.91 for the height and years relationship. That is a pretty strong positive relationship. The other one, the age and helmet wearing, is negative 0.92. It is also a very strong relationship, but in this case, it's inverse. It's negative and it's falling to the right. So the correlation coefficient, or the Pearson R, varies between -1 and +1. Now, if you look at both of these scatter plots, the data points are in a perfect line. That is a perfect relationship or a perfect correlation. So the one on the left is a negative correlation. The data points are perfectly lined up. There's no variation there at all. And the one on the right is a positive correlation, and it's perfect. All of the data points are right on that regression line. Now, in the middle, if you look at this data plot, at this scatter plot, there's no way to put a trend line in there. Those data points are all over the place, and this shows absolutely no relationship between the X and the Y. Now, these two are both really quite strong relationships. Notice where the data points fall. In the one on the left, which is an inverse relationship, that's still a very strong relationship, and it's 0.95, negative 0.95. The one on the right is also a very strong relationship, and it's positive or direct, and that one is 0.88. Now look at these two. The one on the right, you could still draw a trend line through there, but those data points are not as close together or as close to the trend line. And it turns out that Pearson R is 0.33. The one on the left of it, again, you could draw your trend line or regression line, and you would find that the R is equal to negative 0.42. Now, looking at all of these scatter plots, the strongest relationship is actually negative 0.95. The next strongest relationship is the one on the right, that's 0.88. And the smallest relationship is positive 0.33. So to sum this up, for correlation, we assign a number that's called the Pearson R. It shows you the strength of the relationship. So 0 means there's absolutely no relationship there between the data points. And it goes all the way to either a plus or a minus 1.00. The Pearson R also shows you the direction of that relationship. Is it positive or direct? And that means the X increases, the Y increases. Or is it negative or inverse? When X increases, Y decreases. Now, one big caution with correlation. You cannot say that one variable causes the other one. So we don't say that the kid's age causes them to quit wearing their helmets. That is not something that you can come up with from correlation.